people, if you look at this problem, this is quite an interesting one, really interesting one. Yeah, here we have been given an aluminium ball, and the density is 8500 kilogram per meter cube, and the diameter of the ball is 10 centimeter. They say that it's been placed in water. Of course, it's going to sink because the density is 8500 kilogram per meter cube, and the density of water is 1000. Yeah. So, will it float or sink? But they want us to give them the mathematical calculation. So, we will give them the mathematical calculation. And then we are said that if the ball is melted and if it's made into a hollow box of sides zero point 0.2 meter, then will it sink or float? That is the next question. They are also saying if it floats, how much of it will stick out of water? Well, if they have really gone to the extent of asking this question, how much of it will stick out of water, then I think it is going to float. But let us not just assume things. Yeah, let us do the mathematical calculations, shall we? So, for any body to float, we know that the weight of the body should be equal to the buoyancy force. Yes? So, let us just work based on this. So, the weight of the body is the buoyancy force, which is nothing but rho g rho gv. Yeah, so rho gv is the density of the object is 8500 times 9.81 times the volume is nothing but since it's a ball, so it's a sphere, so the volume is 4 by 3 pi r cube. That is the formula for volume. So I just have written the volume. We know the radius. If the diameter is 10 centimeter, the radius is 5 into 10 power minus 2 meter or 5 centimeter. Yeah, so I've just substituted everything, and then I get the weight of the ball or weight of the body to be 43.7 newton. Yeah, so if weight is 43.7, what is the mass? It's so very simple. Mass is nothing but weight divided by gravity, because weight equals mass times gravity. So mass should be equal to weight divided by gravity. So the weight is 43.7 divided by gravity is 9.81, and I get the mass of the body to be 4.45 kilogram. So now you know a 10 centimeter ball of aluminium weighs 4.45 kilogram. Yeah, so now my dear people, when the body is fully submerged, yeah, the buoyancy force is rho gv. So now let us look at the water. So the density of water is 1000, gravity is 9.81, and if you when you think of it, the ball, when it is submerged in water, the volume of the ball equals to the volume of the water. Yes or no? Water displaced. So the volume is 4 by 3 pi r cube, and the buoyancy force I get is 5.14 Newton. Yeah. So what do we know? If the body is supposed to uh, if the body is supposed to float, the buoyancy force should be higher than the weight of the body. But unfortunately, here the buoyancy force is 5.14 and the weight of the body is 43.7. So the weight of the body is greater than the buoyancy force, which means that the object will sink. That's it. So we have answered the first question. Now they are asking us if the ball is melted to form a hollow box of sides zero point 0.2 meter, then will it sink or float? Yeah. So if it is, I'm going to do exactly the same thing. Exactly the same thing. Yeah. It's just that the shape is different. So the weight of the body is exactly going to be the same. So even though the volume changes, the weight is going to be the same. Yeah, because it's the exact same ball that's been melted and formed into a cube. So weight of the body is 43.7 Newton, which we got from the previous calculations. So FB, the buoyancy force when it's fully submerged, is rho GV. Rho is the density of water. This is the gravity. V is the volume of the, what is it? The cube, which is zero point 0.2 meters. So point, when we say hollow cube, it is 0.2 meter times 0.2 meter times 0.2 meter. So 0.2 cube, and then we get a value of 78.48. Now, my dear people, look at this. Here the buoyancy force is greater than the weight of the body. Do you see? The buoyancy force is 78.4, whereas the weight of the body is 43.7. So since the buoyancy force is greater, it will float. Do you see? The same ball, yeah, aluminium ball, when it was a ball, otherwise when it had when the volume was what is it, when the volume was small, it sank. But then when it was made into a hollow cube, it floats. Yeah, now we have been asked what is the fraction of the what is it, the cube will be above the water. So this is a really simple thing. The fraction that will be above water, yeah, is nothing but, so if x is the amount that it sinks, yeah, and the total height is h, it depends on the specific gravity. Specific gravity is nothing but the relative density of the object. So x equals the amount that is sunk equals the length that is sunk equals the density of the object divided by the density of water, which is nothing but the relative density times the total height. Yeah, so density is nothing but density is mass divided by volume. Yes or no? Yeah. So what is the mass of the object? We found out in the previous slide that it was 4.45, and the volume of the floating cube is point 2, point 2, point 2. Yeah, point 2, point 2, point 2 in the third dimension as well. So 0.2 cube, that would be the density. Yeah, density is mass by volume divided by the density of water is 1000, and the total height is 0.2. So what does it show? It shows that it will sink by 11 centimeter. So otherwise this distance is 11 centimeter. Yeah, 11 centimeter or 0.11 meter. So the total distance is 0.2 meter or 20 centimeter, and if 11 centimeter sinks, we can say that 9 centimeter will be above the surface of water. It is as simple as that.